try to, as quickly as possible, go through some of the fundamental theory that we see in music, and also some of the math that we see inside of music. The main thesis of this presentation is going to be that theory can be something that is extremely useful. It can also be used as something that is really just argumentative to prove why something is wrong. Or it can be used to prove why pretty much anything that you do is correct. But really, at the end of the day, what I want anybody to take away is that if what you're playing sounds good, it is good. Everything that we're going to talk about now is interesting, but I don't necessarily know that a lot of it is essential to know when you go to actually play or perform or solo. What matters is the musical expression that you bring out of yourself, not whether or not it perfectly fits a mathematical equation. But let's get into some of the theory of music. Okay, so the interval spacing of a major scale is whole, whole, half, whole, 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 half. So if we look at that interval spacing, and if we take the keyboard of a piano and we just use the natural notes, so just the white keys, no sharps or flats, just the white keys, and we take that interval spacing of whole, whole, half, whole, 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 half, we have to start on the note C. And if we start on the note C, we get that C major scale. Now, in a minor scale, the spacing is whole, half, whole, whole, half, whole, whole. If we take that interval spacing, and again, just use the natural keys, the natural notes, the white keys, we have to start on the note A, and we get an A minor scale. Now we notice that both an A minor scale and a C major scale use the exact same natural notes, just the white keys. So really, they're the exact same scale. This relationship we see between a major scale and a minor scale is called a relative major and a relative minor. For every major scale that you have, you're going to also have a minor scale that shares the same notes. And conversely, for every minor scale you have, you're going to have a major scale that shares the same notes. Okay, so each note of a scale is also assigned a number. So let's take that C major scale. C is 1, D is 2, E is 3, F is 4, G is 5, A is 6, B is 7, and then C is the octave. It's the 8th note, which is the same as the first note. A major chord is made up of the intervals of 1, 3, and 5 of that scale. So in a C major scale, the 1, 3, and 5 will be C, E, and G. That makes a major chord. What we notice is that the interval spacing is whole, whole, half, whole. C to D is a whole step, D to E is a whole step, E to F is a half step, F to G is a whole step. When combined, that's 3 1/2 steps. Keep that in mind, 3 1/2 steps. Now a minor chord will also take the 1, 3, and 5. In A minor, that will be A, C, E. The interval spacing is whole, half, whole, whole. When we add that up, again we get 3 1/2 steps. Now we just discussed 1, 3, 5 as being the triad that creates a chord, either a major chord or a minor chord. Now this pattern of chord triads extends up the scale. So let's look at the key of C. Again, if we start on tonic, the 1, we get C, E, and G. That's our 1 chord. That makes a major chord. 2, we get D, F, and A. That makes a minor chord. The 3 chord is going to be E, G, B. The 4 chord will be F, A, C. The 5 chord will be G, B, D. 7th chord will be A, C, E. 7th chord will be B, D, F. And then we get back to tonic. So if we go up that major scale, what we find is our 1 chord is major, our 2 chord is minor, our 3 chord is minor, our 4 chord is major, our 5 chord is major, our 6 chord is minor, our 7 chord is a diminished 7, and then we get back to our 1 chord, a tonic, which is a major. We notice there that we use uppercase Roman numerals for our major chords and minor case Roman numerals for our minor chords. I might have said that wrong. We use an uppercase Roman numeral for our major chords and a lowercase Roman numeral for our minor chords. Okay, let's look at the circle of fifths. So the circle of fifths moves in a clockwise motion, increasing in increments of, you guessed it, fifths. If we look there first, C, D, E, F, G. That's a fifth. Now let's look at that interval distance. C to D is a whole step, D to E is a whole step, E to F is a half step, F to G is a whole step. Add that together and we get 3 1/2 steps. Now on the inner concentric circle of our circle of fifths, we see that we have the relative minor to every major key. So here's C major. Its relative minor is A minor. Okay, let's talk about tritones. A tritone is the distance of 3 full steps. Now, why does this matter? Because if we take 3 full steps, we can divide an octave equally into 2 halves. What's interesting is that middle point of any octave doesn't actually exist in the key. But if we were to take, for instance, the C scale, C, D, E, F, and then to get that full 3 steps, we land on F sharp. That distance between C to F sharp is a tritone. And then also from that middle point F sharp to C we get another tritone. 3 full steps. Now this is an important mathematical equation that we see come up in music a lot, and it's often emphasized in jazz. The note directly opposite of a note in the circle of fifths is going to be that note, that tritone that equally divides the octave of the starting point. So if C major, we look directly across from it, we see F sharp. F sharp is going to be the note that evenly dissects 2 equal halves of the octave C. Okay, let's look at the chromatic circle. Now, in the circle of fifths, we're talking about either major or minor scales, which uses the interval spacings that we discussed before. In a chromatic scale, we don't skip any semitones. We play every single semitone. C, C sharp, D, D sharp, E, E sharp, F, G, G sharp, A sharp, B, C. Now the chromatic circle looks very similar to the circle of fifths. We see that directly across from it, we also identify the tritone that evenly divides that octave in half. So again, for C, we see the F sharp. Now a tritone naturally exists within a major and minor scale as well. In a major scale, the tritone occurs between the 4th and the 7th scale degrees. So in C, C, D, E, F is our 4th, F to G is a whole step, G to A is a whole step, A to B is a whole step. So we see we get a tritone between F and B. I played that wrong. So we get a tritone between F and B. In a minor scale, we see a tritone occurs between the 2nd and the 6th scale degrees. A, B is our 2nd, B to C is a half step, C to D is a whole step, D to E is a whole step, E to F is a half step. If we combine all of that, we get, again, 3 full steps, a tritone that occurs between the 2nd and the 6th scale degree. We also see tritones occur in a dominant chord, so in a dominant 7th chord. The tritone occurs between the 3rd interval and the 7th interval. In a C scale, the 3rd is E, E to F is a half step, F to G is a whole step, G to A is a whole step, A to B flat is a dominant 7th, is a half step. Add that together, and we get 3 whole steps. We also find tritones in diminished chords. Now, John Coltrane, he introduced a circle as well that uses a lot of math in it. This is his way of rationalizing a lot of things, and we see some interesting occurrences. Let's start on C again. We see that C is flanked on the bottom by its chromatic relative notes, so notes that are closely related to it. B to C is a half step, C to C sharp is a half step. If we look directly down, directly across from C on the outer circle, we get F sharp. We already identified that F sharp is that note, that tritone that divides both halves of a C major scale evenly. If we look across on the inner concentric circle from C, we get F. F is the 5th of C. If we look to the right on the inner concentric, or to the left on the inner concentric circle, we see the note G. G is the 4th of C. There's a lot that we can look at and discuss inside Coltrane Circle, but that's a couple of the highlights that we've already compared to the circle of fifths. You'll also note that in the circle of fifths, when you move clockwise, it equals the 5th, C, D, E, F, G, and then when you move left counterclockwise, you see the 4th, C, D, E, F. Okay, so why does what we've discussed matter? Well, let's first talk about relative majors and minors. For me, what that means is it really expands our ability to understand where we are in the neck of the guitar and gives us more options to our scales. It really opens up our playing and gives us more tonal options and area to cover. Tritones, they're often used to create tension, pulling toward a resolution, such as in a dominant 7th chord or a diminished chord, pulling toward that resolution. That's something that we see in a lot of cadences. A cadence really pulls toward that final resolution of tonic. And once you hit tonic, it just feels complete. It feels resolved. Oh yeah, modes. So think back to when we talked about how each interval of a scale has a corresponding chord by adding the next triad, 1, 3, 5, above it. We said that in a scale, the first chord is, in a major scale, the first chord is major, the second chord is minor, third chord is minor, fourth chord is major, fifth chord is major, sixth chord is minor, seventh chord is a diminished, and then we return back to tonic, the one chord which is major. Now similarly, we can play a scale based on every single interval of a scale as well. The way this works is just by starting on the next note within a scale and playing the subsequent 8 notes or octave. So in C, the first Ionian mode would be C, D, E, F, G, A, B, C. The Dorian mode would just start on 2, D, E, F, G, A, B, C, D. And remember, each of these modes correspond to the chord. So Ionian would be that one chord, that tonic major. The Dorian would correspond to the 2 chord, the minor. And it goes subsequently through the Phrygian, which starts on 3, Lydian, Mixolydian, Aeolian, Locrian. Okay, so why do modes matter? To me, modes really open up the fretboard. There's a lot of discussion about how every single mode has its own feeling or flavor that can be added, and I think that there's value to be said to that, but really I think what you need to do is just understand what you can use, what frets you can use on the fingerboard, and then listen to musically where you want to go with that. Understanding how the modes fit together really gives us a lot more area to play. Okay, so we have some common chord progressions that we see used frequently in music. One of the most common ones is 1-4-5. 1, 4, 5, 1. We hear that in blues. And a lot of rock and roll uses that. Another common progression is going to be 1 major, 2 minor, 5, 1. Another common progression will be 1 to minor 6 to 4, 5. Another common progression is 1 to minor 6 to minor 2 to 5. 1, 4, minor 6, 5. 1, 5, 6, 4. So we have these common progressions and these cadence resolutions that we see very frequently. A lot of times, the ones that I just showed, we see in pop music, rock, blues, soul, country. Very, very frequent that we see those used in modern music. Okay, so we saw how modes can really expand a scale by adding more patterns that still fall within the notes of that key. We also should discuss the numbering of a scale as it moves past that first octave. So we know in the first octave we have 1, 2, 3, 4, 5, 6, 7, and then 8 is the octave. 8 is the same as tonic, so we refer to that as 1. 1, 3, and 5 will always be referred to as 1, 3, and 5 because they're the building blocks of the triad for that key. So in the first octave, like we said, we have 1, 2, 3, 4, 5, 6, 7. We get back to 1. Then we get to 9. 3 remains 3. 11. 5 remains 5. 13. So this is important for understanding chords which add additional tones to them. We discussed the dominant 7 before, a major 7, a ninth, a suspended 4, an augmented 5, a 13, and so on. One of the examples that I use for this discussion is when I'm teaching a beginner student how to start playing chords, I'll use very, very basic shapes. And sometimes they will leave off some of the fundamental tones of a tritone. So take, for instance, this simple D that I teach students. Now, it can be argued that F sharp is not present in this chord shape, and so therefore it cannot be a D major scale because the major third is not present. Well, my argument will be, okay, but the ninth is there, so I'm emphasizing the ninth, that E. So I'm still playing a major 9, and harmonically it can support a melody. So let's take the same melody. We'll just make something up right now. Do you feel that either of those two progressions either supported or contrasted or harmed the melody? I would argue that both really did support the melody and gave the harmonic structure that was influential to making the point. In fact, a lot of times when I'm writing music, I will try to add dissonance into the chords, or I'll try to make it a little bit complicated to understand where the chord is resolving to. I think that if you play cadences that are a little bit too predictable, then, well, just like that, the listener can predict what's going to happen next, which takes a little bit of the interest out of the experience. I like to leave things a little bit open. I'm a big fan of chords like nines. Or how about country? Country is full of semitones. When you're playing country licks, you're using a lot of notes that don't necessarily exist within the key, but they still work. They're still leading. They're leading tones that keep the music moving. Again, groove and feel. How about playing outside of the box? So playing outside is another thing that guitarists end up striving for, where they get tired of playing notes that only exist within a scale, and they want to add more interest to their playing, things that catch the listener's attention. Listen to Sean Tubbs. I think he does some excellent tutorials on talking about playing outside of the box. He was Carrie Underwood's guitarist, and he does some really, really cool stuff with it. So at the end of the day, really what we come to is that we can either argue that something is right or wrong based on the building blocks of theory, or we can also argue why it's acceptable because it either falls into something like chromaticism or leading tones, but really, at the end of the day, what matters is if it sounds good, it is good. All right, that's going to conclude this lesson. There's a lot more to talk about here. We really didn't get into to any of the advanced or jazz chord structures. We touched very briefly on modes, but there's a lot more to explore there. But this gives you just a basic, condensed look at theory, and also gives you the principle and a reminder that, hey, play so it feels good.